Hello, today we're going to see how to set it up Wago IO Link Master module part number 750-657. So we're going to be connecting a Balluff linear encoder, part numbers over here, BTL6U110 M0400-PF-S4. So go to the Balluff website and type the part number of this linear encoder if that's the one you're using. Scroll down and look for device description file, IODD. Download this file, and this file in your computer, you're gonna have to use this to add this to the Wago DD file to your folder that holds the IODD files. In my case, it's under my C drive and users and under public, and there is a folder called Wago software, and there another folder called Wago. Under Wago software is IODDs. So this here are the IODD files that I have for slaves preload already for my Wago software folder. So in my case, it's C drive, users, public, Wago software, and there is a folder IO-link DDs. This is the folder that you're gonna install the device IODD file that you're gonna get from your manufacturer. Next, you're gonna see how to configure the IO Link Master from Wago using Wago IO Check 3 software. So with your PLC in stop mode, you need to put the switch in stop mode and select 750-67, right click and select settings. Now under settings, we have the master configuration and the 4-channel configuration that you're gonna have to enter data depending on how many devices you have. Before you do that, I recommend that you go in a data frame, select here, and the process image that's gonna be the image gonna be communicated between the PLC and the 657. You can have between 4 bytes to 24 bytes. I'm gonna leave default 24 bytes, and also the mailbox I'm gonna leave default as a 2 bytes. Mailbox is another way you can send command between the PLC and the link master. Since you're not going to be using the mailbox to do those commands, you're going to leave this for the menu. Hit OK, and recommend you to go to the port configuration, and let's start port number 1. So you need to go in operation mode and select IO Link. And here you're going to have a drop-down menu for several devices. You have already pre-configured the IODD file. So you need to find your device over here in your list. In this case, that's my stack light. Select that, and here is the cycle time you're going to be pulling that device. So we're going to use 60, for example, and time base at 4. Going to give you 30.4 milliseconds. Every 30.4 milliseconds, we're going to be pulling that device. We're going to disable parameter server, and here this information here you need to get either from the manual of the stack light or the other IO link device, or from the IODD file. Now here to the left, I open already the IODD file for the stack light that we're going to be using. So if you go and looking for information here, we need to find revision number. So revision number, you can see here. If you can go here and go edit, find, and type revision, and find next. Let's find out. First line here is 1.1, so you just go here and you type 11. Then you have the vendor ID, it's right here. The vendor ID is right here. So it's a decimal 88. So you can copy that, launch your calculator, and put in decimal here, Control V. So 888 in decimal is 0378. So notice that the vendor ID has two fields, number 1 and number 2. So you're gonna do 03 and 78. The next field, you need to put the input PD length. So the parameters for the input image between the PLC and 657. So you can go here and search for example, PD, Paul David, and keep hitting next until you see PD in length. So if you see here, PD in segment, 8 bits. So IO-Link always consider bit length. So you enter here 8 bits. So the next thing you're gonna have to enter is the device ID. So if you look here, device ID, it is 330248. So copy that, bring that to your calculator, put in that in decimal, paste it, and hexadecimal is 05. So you break it down, right? Device ID 1, 2, and 3. So 05, 08, and 08, and 08. And here is the PD length out. So you need to go back again here, and go here, find, and PD. So we already found PD in as a 8-bit. We're looking for PD out. So right here, PD out, big length, 64 bits. So you enter 64 bits here. And that's it. That's the only configuration you need to do for the light. Next one is the port number 2 or channel number 2. We're going to go here in active IO-Link. And we're gonna pick our encoder. This is my encoder. Put a multiplier of 60 and time base 0.4. I'm gonna disable parameter server. So revision ID, it's 11 again. You can see here, go here and find and look for revision. Oops, let's go up. Right here at the profile, revision 11. So you're gonna enter 11 here. Again, the vendor, since it's Balluff, is the same 888 that we did for the stack light. So 888, if you remember that, if you copy here, put a decimal and paste, is 0378. So first part, vendor ID is 03, second part is 78. Now the PD in, what this device is going to be sending into the module, what is the PD in length? So we're going to go edit here, find, you're going to put PD, Paul David, enter Paul David here, and until you can see down here, PD in length 32. So we're going to do 32 bits here. And the next thing is device ID. You need to enter. So here's the device ID. So we're gonna go highlight this, copy, go in a calculator, decimal, paste it. So hexadecimal is 03. Again, dividing that in 3 different areas: 03, 01, 01, and there is no PD out, right? It's an encoder in this case. We don't have for this particular model output. If you go here looking for PD out, you're only gonna find PD in. So this take care the configuration of the 2 ports. The other 2 ports gonna be disabled. Channel 1 is my stack light. Channel 2 is my linear encoder. And we got those data from the IODD file. Now we're going to do the master configuration. So I recommend to do an alt calculation. That way you're going to be avoiding any mistakes. So tell it here to enter 1. If you mouse over, you're going to see 4 bytes here for the port number 2, correct? We said 32 bits. 32 bits is equal to 4 bytes. And here the output, it is 8 bytes. So we have 1 byte input from the stack light back to the PLC, 8 bytes output from the PLC to the light, and we have no command, no output downstream to the encoder, but you have 4 bytes coming back. So it's important that you see the SIO byte, it's offset of 3 and length of 1, and keep in mind that we have also process image of 24 bytes and mailbox 2. This is important because when you go in PLC and look for the data coming back, you need to count that you have a status byte, 2 bytes of mailbox, and 1 byte of SIO. And after that, you're gonna get this byte for the light and 4 bytes for the encoder. We're gonna see that in a second. Now you need to connect to our PLC and the devices. Gonna be pulled by the PLC module, and you're gonna go here and before we go ahead, and you just want to double check if the configuration is there. For 1 or 2, you can see the baud rates here selected. It's faster for the encoder, light is slower. But after you check all the configuration, and also for the master, if everything is correct, then you go here and write all parameters to the module. And after this complete, to save to the module. Otherwise, if you select the power, this configuration is going to be gone from the 657. This configuration just created is held by the 750-657, not in the PLC, the way we're doing here. So after you write all parameters, you need to select also save as user settings. Go ahead and do that. After this is done, your configuration is saved in the PLC. Your configuration be saved at the IO link master, not at the PLC. Sorry about that. And you can power down, power up. The configuration be held by the 750-657. Next, we're gonna see how we're gonna lay the input data that coming from the 750-657 module, considering that we have 1 byte input for channel 1 for stack light, 4 bytes input for the encoder, and 8 bytes output for the stack light. We have 1 byte for the SIO byte with the offset of 3. And if you remember, when we were offline, the data frame here shows our mailbox. It is set to 2 bytes. It's important to remember that when you're going to go now switch environmentals, we're going to go to the eCockpit. You're done with IO check 3. So let's disconnect. You can close this. If you want, you can save your configuration, but we're done with this configuration for the IO check 3. And I'm going to save just for the sake of have this. And close it. Now we're going to check the process image data between the PLC and the IO link master. On page 33 of the 750-657 IO link master manual, you're going to see the process image. It has input data and output data. So it could be vary between 4 bytes to 24 bytes. I'm leaving default 24 bytes, and I'm using a minimum mailbox of 2 bytes. So consider this for the input at the eCockpit. the programming program that we're gonna see next. So the status byte is 1, the mailbox 2 bytes. I said that to 2 bytes, I showed already. So 1, 2, 3, and then we have the SIO bytes. After that is the first data coming from the devices itself. So the first byte coming from my stack light, that's channel 1, gonna be byte number 5. 1, 2, 3, 4, 5. You can double check here when you check the SIO byte, that is an offset of 3. So if you go back here and look that, so 1, 2, 3, and that's the offset. So the SIO byte is the position number 4. So that is 3 bytes offsets and 1 byte length for the SIO byte. After that is the data that's gonna come from the IO link slaves. And same thing for the output. You're gonna have a control byte for the IO link, then 2 bytes for the mailbox, 1 byte for the SIO, and after that, gonna be 8 bytes for the stack line. So byte 0 to byte 7, there are 8 bytes controlling the stack line, and there is no byte for the encoder. And basically in this side here, we're gonna have the first byte for the stack light, and byte 1 to byte 4. 1, 2, 3, 4 for the encoder. So this is going to be the encoder data this side here, and this is stack light. And I'll show you how we're going to do this in eCockpit. In this link here, you can request download for 30 days trial period to use eCockpit. That's the programming language we're going to use to program the PFC 100 PLC that we have in our setup. So go to the link over here, fill out the information, and submit the request. You're going to get a link to download Wago eCockpit software. After that, launch the software. So you start a blank program. You can either go in the product catalog over here and type, for example, 750-8100, 8101. You check mark this funnel over here and select the firmware version that you have in your PLC. For example, we're going to go here, launch Wago IO check. We're going to identify and a second here, we're gonna right click and launch Wago Internet settings. And first tab, identification under firmware version. In brackets here, we have a firmware 11 020835. So we do have firmware 11. The latest and greatest is firmware 12, but I'm using firmware 11 for this example. So I'm running eCockpit version 1.5. So there's a blank grid to drop your processors. Different PLCs can be in the same project. In our case, we're going to go in network and scan it. So detect the PLC with the 192.168.1.17. To be able to do this, you need to have your PC in the same subnet mask that you have your PLC or device you're trying to scan it, to be able to see it. So we're gonna wait for the scanner to finish. When this is done, so you can go and apply, here drop and include all modules, all included modules. Apply all scan device to the project, include their modules. You select that, and then there's a difference in compiler for the firmware that we update, firmware 11, and so just hit add, apply devices. Now you're gonna see that eCockpit is reading the modules that's connected to the 750-8101 PLC. And they found three. You see number 3 here? That is 3 modules. One is digital input. The second one is the vibration monitoring, 750-645. And the third one is 750-657. So we can just double click here to see the node. And you see when you add the PLC, automatically eCockpit add the end module, 750-600. Without this module, PLC won't work. So to map the variables from the process image for the input and output, we're gonna go here, double click, or just click in our 750-657, and over here you're gonna see that I hit the plus for the input channel. And also here's the output channel. So you can see there are 0 to 23 bytes, so there is 24 bytes, like we already pre-selected the image with IO check. So the first byte here, if you look at the manual, is the status byte. We're gonna call this SO. So let's go back there, and over here, I'm gonna be B for byte, SO. Then next one over, if you look in mapping, are the mailbox byte 0, byte 1, and the fourth one is SIO byte. Then after that is the devices byte. So we're gonna go here, we're gonna do byte again, and we're gonna say mailbox 01. Then next one over, we're gonna do byte mailbox 02, and third one here we're gonna do byte as fourth one IO. Byte lowercase b for byte as IO, and the next one, it is the stack light and 4 bytes for the encoder. So let's do that. Okay, now we have byte status, the mailbox 2 bytes, the BSIO, then here are the device. Stack light 1 byte and 4 bytes for the encoder. And same thing you can do for the output. But now we're just gonna focus on our input bytes. So you can use those variables in your program. Now we're gonna change to the program side. Go in an application, the specific one, you can rename it whatever you want. I'm gonna right click now, and we're gonna go add a POU, Program Organization Unit, also called as subroutine. We're gonna go here, we're gonna call this, for example, underscore 4 bytes, underscore 2 double words. So we're gonna create a function. I'm gonna use a structured text. I can use different language, programming language, but I'm gonna use a structured text. I'm gonna create a function. The reason I start with the underscore because I cannot create a variable name started with a number. If I do that, I'm gonna get an error. So the IC 61131-3, as you can see here, doesn't allow the standard, doesn't allow a POU name, a variable name, a function name to start with a number. So we're going to start with underscore and hit add. Now what we need to do, we need to get the 4 bytes coming from our encoder. So I click here, I'm gonna go in 657 module. So that is 4 bytes over here, 32 bits. Get us the measurement from the encoder. So we're gonna go in programming, back to programming, in the function block, and we're gonna enter the variable inputs to this function. Gonna be 4 bytes. So all the 4 bytes coming from the encoder gonna be our input for this function. Now the output here we're gonna use for internal variables. We're gonna use an array of bytes 1 to 4 and a pointer to data double word. So basically what are we going to do here, we need to get and we're going to see, okay, so we have internal variables for this function. It's an array of 4 bytes called barray, a pointer to a double word called ptrdw, and underscore 4 bytes to words. This is incorrect over here. This is the return for the function. So we're gonna go here. Okay. So this has to match this. So basically this one here match this one here. So that's what we're going to be taking the pointer that we have in this array 1 to 4 and you're going to pass for a double word. I hit F2 key and I'm going to go under module calls and under application select my function. You see this type is function, so I hit OK and here's my function. So I have 4 bytes to pass. So we have 4 bytes from the encoder to pass into a double word. I'm going to put a semicolon at the end. Then we're going to call, for example, DW encoder value. For example, colon semi-equals. So what are we doing with this statement here? So it's a double word, it's an internal variable we're creating. You say OK. So basically what we're doing here, we're passing the values from this function over here to this variable. So that's the simple assignment. So requires exactly 4 inputs. So right now all the inputs are blank. So that's the reason that is quick red squiggly line here. So going to byte 1 and you're gonna have F2. Now go into variables, go into the IO config global mapping, and you're gonna get encoder 4. So these are backwards, they are swapped. Okay, the bytes that you're gonna put in byte number 1, you're gonna use byte number 4, and so on. So for example, again, F2, I'm gonna go here, variables, IO config global mapping. I'm gonna do encoder 4, 2, and 3. I'm gonna do F2 again. I'm gonna hit the plus, and I'm gonna do 2 and 4. Select, see my cursor blinking here, F2. I hit again plus and be encoder 1 and hit OK. Now, if you want to check if you have any problem in the logic, you see the squiggly lines went away. You hit F11 on your keyboard. We're gonna do check the program and go view message. That is no error, no warning, and full message. So we are ready to download. So if you go here in application, right click and connect. Then applications currently on PLC, so let's go ahead and say yes. And we're gonna go back to programming over here, program and start PLC. So saying that the switch is in stop mode, so I'm gonna put my physical switch in the PLC to run, gonna hit OK. So right now I have the auto limit. So that's the number when you auto limit. So I put a magnetic in the top of my linear encoder now, that's the value I'm getting. So if I move over, so I'm gonna give my increment in micrometers. So if you want, for example, want to take this and display, so this is where you go in application and you're gonna add a visualization here in the bottom. Say add. And so you go here in your toolbox, for example, and you go in your visualization, go in your toolbox, and for example, I'm gonna put a label here. I'm gonna call this label, click here, go to properties and text. I'm gonna change label to encoder counts. Enter. So that's just a label. Now if I want to go here and put a field to display the value of the encoder, can go ahead here. I can do a meter, or a bar display, but this is the way to do it. There's several built-in way to display this and other powerful visualization elements. So this is where I found, for me, you can do even basics, rectangular. So I'm gonna do a text field. I'm gonna put here, and basically I'm gonna increase a little bit my text field. Go here and go in property in text field, and position and minimize here, text. We're gonna do %s, lowercase s, and micrometers. So the %s gonna read the value that you're gonna declare in the text variable here and display it. So remember on the text, %s micrometers. So if you go on the text variables here and click in 3 dots, then you can go in the application, PLC _PRG, double word encoder value. That's what we created, and that's it. Now you need to go ahead and right click and connect. Download the boot application. So if you look at the program itself, the value of the program PLC PRG, so we're gonna go view, vertical. So we're gonna close this function. So basically what I have here, I'm displaying the value that we're calculating, the 4 bytes coming from the encoder. I'm putting them in order and adding to a double word. So they are here. So that's the value I'm reading from the linear encoder. Okay, that's it for now. If you have any questions, please feel free to email me or send me a text. Information is going to be in the description below. And I hope you enjoy this, and let me know if you have any questions.